Hello, today we will study derivative or differentiation of trigonometric function. Okay, so we have to we only need to memorize on this formula: derivative of sine of x equal cosine x. Sine cosine. Derivative of cosine x is sine x, but with minus sign in front. Derivative of tangent x equals secant square x. Remember secant x equal 1 over cosine. Okay, and also derivative of cotangent x equal minus cosecant square x. Okay, and cosecant x equal 1 over sine x. Remember, just you have to memorize, and there's no way to prove. You don't need to prove. Okay, so and also we have differentiation of inverse trigonometric function. That means arctan. Derivative of arctan equal 1 over 1 plus x infirm 1 plus x square. Okay, so arctan of x. Also, like you can write tangent minus 1 of x. That's inverse. And the derivative of this y prime will be equal 1 over 1 plus x square. Okay, how about the derivative of arccosine? Will be equal 1 over square root of 1 minus x square. And derivative of arcsin x equal 1 over square root of 1 minus x square. Okay, and derivative of arccosin equal minus 1 over square root of 1 minus x square. So there are 8 of them. You have to remember. There's no way you can just look it up and try to memory. So the only way to memorize all of this, you have to do exercise and homework. Do a problem, keep over and over, and then you will remember it. Okay, so again, the first 4 trigonometric functions: derivative of sine x equal cosine x, derivative of cosine x equal minus sine x. This is too easy. Okay, now go to tangent. Tangent will be secant square x. Okay, and cotangent will be minus. Remember, cosine and cotangent will be minus cosecant square x. And then inverse trigonometric function, derivative of arcsin x will be 1 over square root 1 minus x square. Derivative of arctangent x equal 1 over 1 plus x square. Okay, and derivative of arccosine will be minus 1 over square root 1 minus x square. So again, if you want to do homework, in order to memorize this is the only way you have to do homework. Okay. Okay. Now the next thing we will go over. We have using log to type derivative. Okay, suppose y equal like x to the x. Okay, so derivative of this equal what? Okay, again, we cannot use power. You cannot use power rule. You cannot apply the y prime will be equal. Take x down, x minus 1, that's wrong. Because x is the function, it's not the number. Okay, so in this case, you have to use natural log. Okay, if from this side, if you take both sides, L and Y, so you have to take x down. The first thing you have to take x down. So in order to take the power down, the only way to use, you have to use natural log. Okay, take natural log of y, and also take natural log of x to the x, okay? Alright, and this will be equal, ln y will be equal 1 over y. Okay, and then from here you will take the derivative both sides. So take dy over dx of ln y equal derivative of dy over dx of ln x, okay? Okay, so, okay, ln x will be equal x ln x, okay? And you take the derivative of this. Okay, on the left side, derivative ln y equal 1 over y dy times dx. Remember this is y, not x. We take the derivative, expect with x. So y is constant, so you have to multiply by derivative. Okay. On the right hand side, because it's x, so we can take derivative directly. So x is a variable, so we use product rule. So x will use x times ln x. So you have like, we have like the first one, derivative x times ln x plus derivative of ln(s) times x. Okay, and this will be equal 1 times ln x plus derivative of ln(s) equal 1 over x times x. Okay, and this one will be equal ln x plus 1. Okay, with x greater than 0. Okay. Okay, so now we have 1 over y dx dy will be equal 1 plus ln x. Okay, if you remove y from the left side, if you move to the right hand side by multiplication, then you have dx over dy will be y times 1 plus ln x. Okay, but we take the derivative or dy over dx, sorry, okay, dy over dx okay, so y in this case is constant, a number, okay, a fixed value. Okay, now let y will be equal what? Y equal, okay, here y equal x to x power, then the final will be equal x to x times 1 plus ln x. Okay, that's the final answer. Okay, remember when you take the derivative of the power with something power to the function, with a function power that you use derivative, you to use a natural log to decrease the power, to take down this power. Okay, and then somehow you replace y equal the original function into derivative of y right here. Okay, then you have the derivative of derivative respect to x. Remember, dy over dx, that means the derivative of y respect to x. Okay, this is different than derivative of dx over dy. Okay. Okay, let's find another example. Y equal s ex. Okay, y equal x to e power of x. So find the derivative y prime. When you say y prime, that means you find dy over dx. Y, this one called derivative of y respect to x. X is variable. Okay, so again, you cannot, here you have to take down e to power of x, so you get take natural log both sides, then you have ln of x dx, and this will be equal ex ln x. Okay, and then take the derivative dy over dx both sides, dy over dx over ln y will be equal 1 over y. Okay, and this will be use the product rule. The first derivative is the first function e of s. E of s is like derivative es equal es and multiply by ln s plus derivative of ln s equal 1 over x multiply by second, the first one, e of x. Okay. Okay, here, this one. The derivative of the first one by the second one plus the derivative of the second one by the first one. Okay, and we relate to this point right here. Okay, so here, so we have ex ln s plus ex over x. Okay, and dy over the x type 1 over y. If we multiply both sides by y and move y to the other side, then we have dy over dx will be equal y pi to the whole thing. Okay, like this. Ex ln x plus e to the power of x divided by x. Okay, but y will be y equal this one. Replace that. Y equal x to e to the power of x. So we replace that y equal e. Y equal x power e power x to e x ln x plus e x over x. Okay, that's the final answer. Well, you can multiply and simplify, but it's not necessary. We will accept the answer right here. Okay. Okay. So today we'll study the derivative of trigonometric function, sine, cosine, tangent, cotangent, arcsine, arcosine, arctans, arcotans, and take the derivative by using log. Okay. Okay. So I guess you just go home and do homework and to remember the derivative of those 8 trigonometric functions, and just apply some, find some exercise to apply this log to take the derivative. Okay. Alright, so I see you next time.